Hello dear students, welcome to my channel. In this video we will see hybridization in alkane. So particularly we will see SP3 and SP2 hybridization of an alkane. So myself Professor Vikrant DhamaK and I will be talking about SP3 and SP2 hybridization of an alkane. So for more updates, subscribe the channel and also like the video. Now let us understand what is firstly an hybridization. Hybridization is the concept of mixing of two atomic orbitals with the same energy level to give degenerated new type of orbitals. So degenerated, it means giving the same energy level of an orbitals. And here two orbitals, they are been mixed. So two orbitals like SPDF. So there are certain kinds of an orbital and these orbitals they get mixed. Atomic orbital of same energy level can take a part in hybridization and both fulfilled in half-filled orbital can also take part in this process provided they have equal energy. When we will learn electronic configuration of an carbon, at that time I will explain this part. So here hybridization can take place mainly s orbital it is been fulfilled, whatever the examples we will see. So s orbital it is fulfilled and p orbital it is half filled. So I will explain that how it becomes of an equal energy. During the process of hybridization, atomic orbitals of same energy are mixed, such as mixing of two s orbital or two p orbitals, or mixing of s orbital and p orbital, or s orbital and d with a d orbital. In this case we will see mixing of ss orbitals or sp orbitals. We are not having an example of an s orbital with a d orbital. So we will see how it happens actually. Let us firstly come towards types of hybridization. So there are three kinds of an hybridization in case of an organic chemistry. There are also apart, but there are three main, that is SP3, SP2 and SP. So these are the three main, and there is also when it comes to a D block element, so there are some hybridization also. In our case, we are having only two kinds of an hybridization, that is SP3 and SP2. So these two hybridizations that is part of our syllabus. Name itself indicates that one s orbital, right? One s orbital and three p orbital belonging to the same shell of atom mixed together to form a new 4 equivalent orbital. When they move towards an excited state from a ground state, when they become an hybrid, so there is mixing of one s orbital and three p orbitals. The type of hybridization it is called SP3 hybridization, or it is also said to be a tetrahedral hybridization. And this tetrahedral hybridization it is called because when we will come towards the geometry of that molecule which is formed after an SP3 hybridization, it is tetrahedral geometry. And this newly formed orbitals, they are said to be an SP3 hybrid orbitals. These are directed towards the four corners at regular tetrahedron and make an angle of 109 degree and 28 minutes with one another. So I will explain with the help of diagram this part. Each sp3 hybrid orbital has 25% s character and 75% p character. See this, as you can see, s, right, it is only 1 and p it is 3. It means that 25% character it is of an s and 75% character it is of an p. So let us take an example of an sp3 hybridization, that is ethane or methane. So we will take one example how the hybridization it takes place in case of a methane. For an example, let us take an hybridization in an alkanes, and we will take the example of an methane for that purpose. The atomic number of an carbon and atomic number of hydrogen. So to understand this hybridization, one should know the atomic number of carbon and atomic number of hydrogen to know its electronic configuration. So electronic configuration, I will consider that you are knowing the electronic configuration. So atomic number of carbon, it is 6. So electronic configuration, it will be 1s2, 2s2 and 2p2. So totally it becomes now 6, and electronic configuration of an hydrogen, it is 1s1, because the atomic number, it is only 1, so only one electron it has been filled in one of the shell. Here are 6 electrons present in the carbon, so 6 electrons they have been filled as per the energy levels. So these are the energy levels of an orbitals. So let us consider now, I have written an electron configuration over here. So 1s, so we will not deal with this 1s2 because see, when it's an octet, that octet has to be completed. So the first shell, it is of an 2 electrons, and second shell, it is of an 8 electrons. So we are concerned with this octet only. This 1s2, it is not a part, it will not take a part in an hybridization. So we are concerned with this only 2s2 and 2p2. So in the block diagram, I have written with an opposite spin. So always it should be an opposite spin. It should be not of an same spin. So it is at a ground state. So you can see the energy difference. P, it is having a little bit higher energy compared to an S, and this 1s2, it has an more or less energy compared to this 2. So at the ground state, you can see there are 2 electron in 2s and 2 electron in 2p. The shape of S orbital, it is oval or it is round, and p orbital shape, it is dumbbell, right? So it is a dumbbell shape, or it is called double dumbbell shape, and there are 3, 2p, x, y and z. So they can be mentioned as 2px, 2py and 2pz. At the ground state, you can see the carbon in such way. When it becomes excited state, one of the electron, it get transport towards an 2pz, right? So this, it is an 2pz cell. Now you can see all shells, they are now an equivalent, right? We have to complete the octet, so we will come to that octet also, what actually an octet it is. So there are 4 shells, they are empty, and these 4 shells now need and one more electron to complete the shell, and that is why the reason is that the valency of carbon, it is 4, because there are 4 vacancies, or 4 electrons are to be needed to fill in this shells. Now once it becomes an hybridized, once it becomes of an equal energy, so you can see the energy difference over here also with the help of this arrow. But when it becomes an hybridized, all the cells, they becomes of an equal energy. So there is mixing of one s orbital and 2p3, 3 orbitals of an p. Now further, you can see that there are 4 orbitals now, and these 4 orbitals, they are around the carbon, and the angle between them, it is 109 degree and 28 minutes. So we will come to that point also. Now as I was explaining that here there are 4 vacancies, you can see as there are 4 vacancies, and that is why the carbon has valency 4, and we need to fill 4 electrons in that. And from where the 4 electrons they will come? So they will come from an hydrogen. As I have explained over here, the electronic configuration of an hydrogen, it is 1s1. So these four hybrid orbitals of an carbon atom, it will mix with an hydrogen and it will form a new bond. So you can see there is a formation of an sigma bond between each carbon atom, between each carbon and hydrogen atom. And this 1s orbital of an hydrogen, it gives and donates an electron in this shell, and it forms the methane molecule. When it comes to this cell, say suppose these are four hybrid orbitals of one carbon. They were having an electrons in the shell, and when the electrons, they are coming from an hydrogen, so I will write hydrogen electron in the another color. When they are coming from an 1s1, so they will get mixed, and it should be of an opposite spin. So once this molecule it has been formed, so it looks in such a way that it is of an opposite spin. And this SP3 hybrid orbitals, red color SP3 hybrid orbitals, so they get mixed with 1s orbitals of a hydrogen. And all the bonds are sigma, because there is no side by overlap. It is all an axial overlap. It is all on the axis. If we see the 3D structure, as we are writing the methane in such a way on the 2D or on the paper, but in actual the 3D structure it is in a such way. So the bond angle between this, it is 109.5 degree and 28 minutes. So all the carbon and between all the hydrogens, the bond angle it will be similar. So this was about an SP3 hybridization of an alkenes. Now we'll see SP2 hybridization. So what this SP2 hybridization is actually, as we have seen in the earlier case that 1s orbital and more 3p orbitals, they combine together and it forms an hybrid orbitals. The sp2 hybridization is observed when 1s orbital and 2p orbital. Again, the name, from the name it can be understood that 1s orbital and 2p orbital of same shell of an atom mixed to form 3 equivalent orbitals. The new orbitals are called sp2 hybrid orbitals. It involves mixing of 1s orbitals and 2p orbitals of equal energy to give new hybrid orbital known as sp2, and the mixture of s and p orbital form a trigonal symmetry and is maintained at 120 degree. So this is the main difference between sp3 and sp2, that the bond angle in case of an sp3 it was 109 degree, and in case of an sp2 hybridization it is 120 degree, and it will different for an sp again. So in this case, there are 3 orbitals that combine together and it forms an hybrid, and it maintains an angle of 120 degree. In the earlier case also we have seen what is the character of S and what is the character of P. As you can see, there are only 3 over here, means 1s and 2p. So the character of S it is 33, and character of P it is 66.66, 33.33 for S and 66.66 for P, because there are only 3 kinds of an orbital, they get mixed and form an hybrid orbitals. Let us take an example, sp2 hybridization in alkenes. So we will take an example over here of an ethylene molecule, or it is said to be an ethene molecule. As we know, the carbon it has an atomic number 6. So if I draw an electronic configuration, it will be 1s2, 2s2 and 2p2. In the ground state, you can see that energy level of 2s it is lower and 2p it is higher, because it is in the outer shell, and as p it is the last orbit. Now one of the electron it will go from 2s to 2p. So as I have explained earlier, let us consider this x, y and z. So there is only combination of s orbital and 2p orbital. One of the it is from s and 2p, not this 2pz. Z it is not forming an hybrid orbital, and I will come to that why it is not forming an hybrid orbital. And now you can see that the electronic this hybrid orbital which has been formed, and it contains only 3 orbits, that is SP2 and 1p that is apart. So here that p it is remaining, that is apart. So it will not it is not involving in a hybrid orbitals. Now the next thing that will happen, see this hybrid orbitals, they will be in an angle of 120, but this p orbital it will be always at a 90 degree to this all hybrid orbitals. So it has been indicated with a different color, and when two hydrogen they get mixed, when they get mixed with an this carbon, so two shells they are been filled, but one shell it is empty. Right here you can see that two shells they are been filled, one shell it is empty, or one orbit it is an empty. Now as we are saying the ethylene molecule, so let us take 2 carbons. Right, we have taken the ethylene molecule, and so we will take the 2 carbons. So the same things that will be happen with this carbon also, as mentioned for this first carbon. The 2 hydrogens they will get mixed, and in both the cases the shells are empty, or the orbits are empty, but it is and at an 90 degree. The pz which is unhybridized, it is at 90 degree to all this. Now these two they will overlap, and once they overlap, one of the electron present in the carbon, that is one of the electron present in this sp2, and another electron present in the carbon sp2, they will get overlapped, and it will form a new sigma bond, which here you can see that this it is not having a hydrogen now. These 2 carbons they are getting overlap, and after an overlapping it forms a new sigma bond. But now the case is that this p orbital they are not form a bond. What happens with this p orbital which are remain to be unhybridized? What happens with this p orbitals? The bond angle between this, as I have discussed, that bond angle it is 120 degree, and the new bond which has been formed between this p orbitals, that is side by overlap, and when it forms in sigma bond, the overlap it is at the axis. The 2 atoms, the 2 shells they mix at the axis, but when it comes to an p, it mix at the laterally or beyond the axis. As we can see over here that this 2p they are mixing with each other, right? So the one of the electrons they are sharing the electrons, as it is also a covalent bond, it is sharing of an electron, and a new pi bond it has been formed. So the concept of a pi bond is that the overlap it is beyond the axis, or it is the lateral overlap, and the overlap which is at head to head or which is at the axis is said to be a sigma overlap, or it forms a sigma bond. When the lateral overlap it forms a pi bond. This 2pz it does not take part in hybridization, only the hybridization it takes the part, that is 2s and 2px and 2py. So these are the three orbitals which take part and which forms this ethylene molecule. And you can see now this hydrogen, if I draw the paper structure or 2D structure, that hydrogens, they are attached to one carbon with a sigma bond, and when it comes to a double bond, so this double bond it has formed due to this unhybridized p orbital of both the carbons, and it has formed a double bond. So this was about an hybridization of an alkenes. That Thank you for watching the video. If you are having any doubts, you can comment me in the comment box. I will surely reply it.